Please title these notes Graphs 8 Notes, Second Derivative Equations, and write today's date. By the end of this lesson, you should be able to do graph analysis with the second derivative as well as the first. This lesson is exactly the same as the graph analysis with first derivative equations that we did previously, except that the translation line is going to be f double prime of x instead of f of x, and we need to take the second derivative instead of stopping with the first derivative. Other than that, it's exactly the same. So let's jump right into some problems. I'll go ahead and write this down first. I'll pause the video if you need another second. Find the x-coordinate might be coordinates, we don't know, of the inflection points of f of x equals x to the fourth minus 2x cubed. So we want inflection points of f of x, so that means our answer line is f of x. Inflection points is concave up, concave down. Because we're working with equations, our translation line has to be plus minus. But now the translation from f being concave up, concave down to positive negative is now f double prime instead of f prime. So that means this is f double prime of x, and from there on everything's just like we did before. We have f of x we need to get to f double prime. So start with the first derivative, or x cubed minus 6x squared, and then take the derivative again until we get there. 12x squared minus 12x. Now once we've got that, we can factor and do our sign chart just like normal. Okay, so we've got 0, we've got 1 up here. So for a number less than 0, so negative 1, 12x is going to be negative. Negative 1 minus 1 is also going to be negative, so overall it's negative. For a number between 0 and 1, so like 0.5, 12 times 0.5 is positive. 0.5 minus 1 is negative. A number greater than 1, 12 times 2 is positive. 2 minus 1 is also positive, so overall it's positive. That means we can translate over here. Positive in f double prime means concave up in f, concave down, concave up. So what this means is it means f of x has inflection points at x equals 0 and x equals 1 because f double prime of x changes sign. So f of x changes concavity. We could also ask about where f of x is reading off this chart right here. So for our second problem, let's find the x-coordinates of the inflection points of f of x if f double prime of x equals 2x, x plus 1 squared, x minus 3 to the third. So, as always, we look for, what are we looking for? Inflection points f of x inflection points are concave up, concave down. We're working with an equation, so this has to be plus minus. F of x concave up, concave down translates to positive and negative for f double prime. And it turns out that over here we already have f double prime of x. No factoring, no derivatives, no nothing needed. So we can find our zeros. So we got -1, 0, and 3. Now we can use this to make our sign chart. So 2x times a negative number is going to give us a negative. Anything squared is positive. Negative 2 minus 3 cubed is a negative. So that's positive overall. Between 0 and -1, so like negative 0.5 times 2, that would be negative. Anything squared is positive. Negative 0.5 minus 3 cubed is a negative. Between 0 and 3, let's say 1. 2 times 1 would be positive. Anything squared is positive. 2 minus 3 is negative. Cubed is still negative. Number bigger than 3, let's call that 4. 2 times 4 is positive. Anything squared is positive. 4 minus 3 is positive. Cubed is also positive. So there we go like that. And now we translate. Positive becomes concave up. Negative becomes concave down. Positive becomes concave up. So remember, we're looking for inflection points. Change is concavity. So that means that this is not an inflection point because concavity doesn't change. We do have inflection points at 0 and at 3. For the same reasons that we listed above. Okay, let's do a check for understanding problem now. Find the x coordinates. That's an x. Of the inflection points of f of x equals e to the negative x squared over 2. Okay, have at it. Pause the video, do your best with it, and come back to me when you're ready. Okay, x coordinates of inflection point. That means we are talking about f of x, concave up, concave down, must translate to positive, negative for an equation, so that means the translation is f double prime of x. So we need to get f double prime out of here somewhere. F of x equals e to the negative x squared over 2. F prime of x, so this is a box function, so it's the same thing, times the derivative of -1/2 x squared. That's another way of writing that same thing. Make sure you do that derivative piece of the chain rule, otherwise it will not work. Notice I'm still on f prime of x. I haven't gotten to f double prime yet. Those cancel out. Okay, We can't stop there though, so we need to get to f double prime. So f double prime of x, we're going to take the derivative another time. Notice product rule. Okay. Once again, we're going to need to chain rule this puppy. So derivative of this is e to the negative x squared over 2 times the derivative of negative 1/2 x squared. This is times, there's a negative x along for the ride, plus e to the negative x squared over 2. Derivative of negative x is negative 1. Again, those cancel out. Funny, it actually ends up looking the same thing as what we did before. Actually, why don't we move that negative 1 to the front here? We can shorten that up, just say minus. Okay. So this is negative x times negative x, which is just plain old x squared, minus e to the negative x squared over 2. And now we can factor that. Remember, the reason that we factor is so that we can find those zeros more easily. If there's wild subtraction in here, then we can't just say 0 plus anything equals 0, because that's not true. It's got to be 0 times anything. So we can factor out that e to the negative x squared over 2. This is x squared. Whoops. Squared minus 1. Now we can factor that even further. Notice if you left it like this, you could still solve it. It would just be a little trickier when we went to do the pluses and minuses. So now we can finally get to our sign chart. E to the negative x squared over 2 equals 0. I really don't care what this is. That never equals 0. X plus 1 equals 0. X equals negative 1. X minus 1 equals 0. X equals 1. So that means coming up here to our little sign chart, I'm going to mark negative 1, positive 1 right there. I'm also going to write my little f double prime equation over here so I can refer back to it without scrolling all the way down the page. You don't need to, you can just look below. E negative x squared over 2, x plus 1, x minus 1. Okay, so for a negative 2 or some number less than negative 1, this is always positive. Negative 2 plus 1 is negative. Negative 2 minus 1 is negative. Positive overall. Number between negative 1 and 1, like 0, this is always positive. 0 plus 1 is positive. 0 minus 1 is negative. Number greater than 1, this is always positive. 2 plus 1 is positive. 2 minus 1 also positive. So then coming over here, negative 1, 1. Positive translates to concave up, negative to concave down, positive to concave up. F of x has inflection points at x equals negative 1 and x equals 1 because f double prime of x changes sign, so f of x changes concavity. This concludes these notes.